Good afternoon, everyone, and welcome back to Architects Product Talk. Before we start, if you want to talk to our representative, feel free to click the button below to go to our online exhibition stand. So, about the topic, how to score green building points for metal roof system. What this topic aims to share with you some of the common points that you can score if, let's say, you want to specify metal roof for your project. So these are some of the common points, and I'll share also the insights behind some of these points, and to give you more insights about why it is achievable for green building. All right. So just a bit background. What are green buildings? So green buildings does not need to be green per se. Does not need to have a lot of greens, right? Like what is depicted in this picture. It is what we call not green but rather sustainable building. So it has to have a large amount of sustainable solutions or designs incorporated within the building design. Right. So of course, throughout the world, and most talk about topics are climate change, global warming, and all that. So buildings and building design play a huge role in contributing, as well as in the future helping with this reduction of climate change, and also steer the whole conversation in another direction. So of course, each country or each organization, they will initiate certain types of rating tools for different country to act as a guideline for them to design a sustainable building. So of course, some of the more recognized one throughout the world, as well as in Malaysia, are like Green Building Index, or in US they normally use LEED by USGBC. And of course, some other rating tools like Green RE. In Singapore, they have PCA, Green Mark, and so on. Right. So these are some of the green building rating tools. Of course, in order for you to achieve so-called green building according to these different rating tools, you might want to incorporate green building products or green building designs. So there are many ways you can achieve it. But for metal roof, of course, there are a certain set of points and certain set of designs that are already out there for you to choose, right? So for metal roofing, right, you can actually look for some of the certificates that are already evaluating metal roofing as a green building product, right? Something like Syrian Eco Label, which it can evaluate the raw materials manufacturing process, whether it is sustainable, whether it affects the environment for the production. Or in Singapore, they have this thing called Singapore Green Building Product, right? Which is a certification of a product, right? So for coated steel, for roofing material, they do offer such guideline of how to quantify, how to classify the product as green product, right? Among others, of course, as you can see here. So the intention here is actually very simple. If I were to simplify into, how does it help or help reduce climate change, is that for a building, there are actually two types of energy that you would spend on a building. So the first one is what we call embodied energy, as highlighted in this blue arrow. So embodied energy is normally plateaued when it's just built, because embodied energy represents the energy goes into producing different types of building material, and also installing onto the building. So that's what you can see from here, right? The x-axis is the building lifespan, right, from 0 years all the way to 100 years. You can see that the embodied energy of a building do not actually change a lot. The possibility that it increase is probably due to, say, replacement of parts, maintenance of certain components within the building, right? Another type of energy is called operational energy. Over here, what you can see is that from starting of 0 year, there'll be zero energy use, right? So simply put, it is the operational energy of the building. And this energy used for operation will actually increase over time because it's a cumulative energy usage, right? From 0 years all the way to 100 years. So of course, what you can see from here is that both will contribute to how a building contribute or emits energy. Of course, the more the energy used for a building, the more not sustainable it is. Meaning, normally we want to aim to have lower energy use for the whole building, right? So, say for example, to allow you to imagine what is embodied and also what is operational energy. So, for a building site, first there'll be energy used to excavate the site, right? To flatten the ground or maybe to create a basement. And there'll be also energy used to build the structure, right? That is a part of the building block of the building. Then there will also be energy used to manufacture and also transport all the building components. Okay, so building components can be manufactured locally, or they can be imported from around the world, right? Depending on the supply chain. Okay, so all the way until the end, when the building is constructed, right? So all this process that I just described is part of the embodied energy. Okay, energy used to construct the whole building. So once the building is installed, then there will be constant energy supply to this building, be it to cool the building or to heat up the building, right? Depending on the weather. But for Malaysia, it's most often to cool the building. So this energy use is part of the operational energy. And cooling is one of the biggest energy used to operate a building, of course. Right. So, as what you can see here, those prior process to completion of the building, those are called embodied energy, and the energy used to operate the building throughout the lifespan is called operational energy. Okay. So what you can see from here is that the graph for operational energy accumulate over time, and then it will actually surpass the total energy of embodied energy at a certain point, right? The cross-section area is where the amount of energy used for operation surpass those of embodied energy. So ideally, you want to lower down these two, right? So of course, I will be giving you 3 points where roofing, metal roofing can actually contribute to lowering different aspects of energy use. So let's start with embodied energy. So the first point is recycled content. Okay, so for different green building rating tools, right? They are possibility of achieving a respective level of points, as well. You can see from this list: GBI in Malaysia, Green RE, LEEDs, and so on, where different rating tools would attribute certain points for recycled content, right? So and recycled content is actually a part of reducing the embodied energy, right? Because when you are recycling, you use less energy to produce back the same amount of product. Okay, so essentially for steel or metal roof, the metal itself is virtually recyclable, and for steel in particular, it is 100% recyclable without any degradation. Meaning, the steel that you take and then recycle again, it will not and the steel that comes out from the recycled process, it should be able to give you 100% of the original quality. Okay, and of course, this takes into consideration of the life cycle of steel, right? So here I give you a brief overview about from the raw material process all the way to the usage of the steel, and all the way to recycling and also putting it back into the raw material production, what we call scrap, right? So within this process, of course, the hardest part right now is actually at the recycling part, because sometimes the building use, it will be very hard for the raw so-called the scrap material to be recycled back into the upstream. So this is where holistic view of the recycled content needs to come in. Of course, over here, what happened is that recycled content can come from two parts. One is what we call pre-consumer content, where there will be a lot of small offcuts of steel coming from production, coming from coating line and all that. And of course, there is another source where we call them post-consumer content, right? So post-consumer means that after the building has reached its end of life, then the steel content will be recycled to become scraps. And these two will combine to become recycled content. And most, if not all, of the rating tools will actually use a certain type of calculation to calculate the overall recycled content. And if let's say you calculate recycled content, right, it's not as straightforward as recycled content from here and here add up together. So apparently there's actually this formula where if you want to calculate the recycled content, you need to add the percentage of recycled content coming from post-consumer content, okay, and half of the percentage of pre-consumer content. These two add up together to become the overall recycled content percentage. So let me use an example. If let's say for a block of steel, which has 5% of post-consumer content and 10% of pre-consumer content, then the recycled content would not be 15%, but it will be calculated as such. So 5% of post-consumer plus half of 10%, which is another 5%. So it will be 10% of recycled content as a whole, right? So of course, this recycled content, if let's say it is above 10%, then you can score 1 point, right? So different rating tools, they will give you so-called the criteria. So for example, Green Building Index, they will require you to give proof of your steel content should contain at least 10% recycled content, right? Something like Green RE, they will require a product certificate, right? The recognized one like Syrian Eco Label or Singapore Green Building Cert, right? And LEEDs would require a lot higher, which is at 25%. And Green Star, which is used in South Africa, requires as high as 54% of recycled content. So all these are actually relevant to each geographical location, because some location, there would be a lot of availability in terms of scrap recycling and how it is being channeled upstream. So some other countries may not have that, right? So of course, moving forward, there will be a much more holistic view on recycled content. So instead of just looking at the percentage of recycled content, it will actually look at the Environmental Product Declaration, or so-called EPD. So how this works is that EPD, they will look at each stage of the process, right? And each stage of the process, because there will be energy used to, for example, melt the steel into molten metal. And perhaps in the construction stage, there'll be delivery from a truck that emits energy also, right? Or emits certain types of pollutants, right? Using usage stage, and also end of life stage, and of course at the end, resource recovery stage. So for embodied energy again, instead of looking just at the recycled content, there will be more scopes to be covered, right? So now, there are companies, including, in our counterpart in Australia, they already have initiated, this tracking system where they actually look at the production stage, okay, as what you can see from here, the end of life stage, and also the recovery, resource recovery stage. And they will look at, how much energy is being used. Okay, so of course, there is, a certain classification, under a certain guidebook, which will highlight, okay, this is stage A1, A2, A3, and so on, right? So, for example, the life cycle that I described earlier. So, by considering all these energy use in different stage, right, it gives a much more holistic view of the embodied energy used for the whole product, right, from the recycling stage all the way to product usage. So, in BlueScope Australia, this is an example of what they have done. Okay, so of course this is a future state for Malaysia, right? This what is supposed to happen, right, in the near future. So something like global warming potential, it is tracked, right, at different stage of the products, right? Perhaps the so-called photochemical ozone creation potential, how likely it is to create a photochemical, right, that could cause harm to, say, the environment, right? So on and so forth. And of course, aside from that, also it will also track the amount of energy used in different processes. So these are very detailed processes where each stage it will look at what are the renewable energy use, what are the non-renewable energy use, like fossil fuel, right, or coal, so on. Okay, so of course here it will actually create more visibility and more accountability in the future, so that when people specify or use steel, they know, okay, is it sustainable, is it using less embodied energy or more, right? So these are some examples, right? So again, to recap, recycled content is just the first step to capture how much of the final product is using recycled content. Of course, ultimately is to reduce the embodied energy. Of course, moving to the second type of energy, which is the operational energy. How much of the energy required to maintain or to operate the building. So of course, for metal roof, the point which would contribute to reducing the operation energy is solar reflectance index. Okay, so solar reflectance index works to reduce so-called the heat gain from roof or from facade, and most often is referred to as the acronym SRI, right? The SRI value of the roof or SRI value of a certain color. Okay, so again, coming back to the rating tools, right? Green building rating tools. Again, there will be respective points being awarded if, let's say, you meet a certain criteria. Of course, some rating tools might be higher than the others. But what is solar reflectance index, and how does it help with reducing the operational energy? Okay, so imagine this. So this is actually a thermal photograph where it actually captures, the temperature of different building components or different areas of, an area. So what you can see from here is that, the darker the color in terms of skewing towards blue, that means the cooler it is. Of course, over here, what you can see is that, plant, straightforward, it will be the coolest because the plant itself, it will actually convert the solar energy into so-called food, right? Photosynthesis. So it will not convert it into heat. But for building material, like for example, the bitumen, or so-called the darker color like the road, it will absorb a lot of energy and solar energy, and then it will actually re-emit it back to the environment. So that's why from this photo, you can see that the road are actually hotter, right? And then for the roof, here you can see two different roof area, the one on the right and then the one on the left. So you can't see this, but actually the roof are in different colors. Okay, and the one on the left is in white color, and then the one on the right is actually in a darker gray color. And what you can see from here is that the roof on the right actually has higher temperature, actually emits back higher temperature compared to the one on the left. So let me just explain this phenomena. All right, so but before I explain this phenomena, I need to explain that for heat to transfer, right? For example, from here, this diagram, this picture, you can see there'll be a campfire, and then there'll be a pot of water or soup, whichever you like to imagine it be. There are actually three types of what we call heat transfer, meaning how the temperature transmit from one like fire to the, say, the bowl, and subsequently inside, the water inside. So there are actually three types of heat, what we call them heat transfer technically, right? Or heat gain. Okay, so the first one is called radiation. Okay, so it works like this using this example. So the fire is emitting, heat from the fire source, right, which is the wood. And due to this chemical reaction and so on, there'll be a lot of heat coming up from fire. And the fire will actually radiate a lot of heat to everywhere where you can see the fire. Okay, of course, the one that will be absorbed, the most will be the one that is closest to it, and of course the one that is darker, which is the pot. And then the pot will turn hotter, so the pot itself will conduct the heat from the bottom all the way to the top. So this is what we call conduction. So this is a second form of thermal, so-called heat transfer. And of course, when it is hot, the pot is hot, then the water inside will be flowing around, and then water will start heating up itself. And that is what we call convection. And this also happens when the steam coming off from the water, it gets blown away, right? So that is what we call convection. So these are the three major types of heat transfer. Of course, when we refer to solar reflectance index of the building, right, it takes into account of the first one, which is solar radiation, right? So as you can imagine, under the sun, there are a lot of areas of the building that are exposed to solar heat or solar energy. And here is actually a spectrum of solar energy that is emitted from the sun and reaching the Earth's surface. And what you can see is that there are actually three spectrums of light, or three spectrums of solar energy, which covers ultraviolet, the visible light, which illuminates the environment, as well as infrared, okay, or near infrared. So the part that you don't really see, but then you can feel the heat, if let's say it's absorbed by the surrounding building components, is the near infrared spectrum. Okay, so how it works is that when the sun shines onto a roofing sheet, okay, if let's say the roofing sheet is a black color, then the solar reflectance is naturally higher. Lower. What it means is that less of the solar energy is being reflected back or not absorbed. Okay, so here, black color, then the roofing sheets will have a temperature, for example, of 70 degrees Celsius. Right. So if let's say you change the color of the roofing sheets to gray color, then the roofing sheets will be in a lower temperature, like for example 55 degrees Celsius, right? Because most of the radiation are not being absorbed and being bounced back to the environment, or not being absorbed, right? So the third one is if let's say the roofing sheet is in a white color, then the roof temperature could potentially reach 40 degrees Celsius. So these actually potentially would reduce the heat gain of the building and subsequently release less heat to the environment. Right. So this is what we call solar reflectance. Of course, there's a way to quantify, how much heat is being absorbed, from the solar energy or from the near infrared energy or wavelength. Right. So from here, there's another consideration which is thermal emittance, which depending on the material's surface smoothness. So over here, what you can see is that from say clay tile roofing sheets, right? Clay tiles roofing. There will be, for example, the roof the tile temperature could be 70 degrees Celsius. The emission of this tile would be at 65 degrees Celsius. So the environment, also called the air around it, would have a 65 degrees Celsius temperature. But if let's say you smoothen the surface, right, then the thermal emittance would be different, where there will be less emittance towards the environment, right? For example, a painted product, right, that has a smoother surface, then the temperature that is emitted back to the environment would be, for example, 45 degrees Celsius, right? So these are the two criteria: solar reflectance and also thermal emittance. These are the two that were actually used to calculate solar reflectance index. Okay, so for thermal emittance, let me show you another example. Right, so this is an example of a toaster, right? That what you can see is that there will be heat coming from grills top at the top and bottom, and what you can see is that there are different materials, like for example the grill, they will emit different heat compared to if let's say it's the glass at in the front, right? So different material will actually have different degree of thermal emittance. So combining these two, which are measurable, you are able to calculate SRI value, right? So so SRI value can be quantified, right? And if let's say you search for SRI calculator online, right, there are actually different calculators where it will be using the same or similar standards to actually calculate all these value from solar reflectance and thermal emittance. And typically, higher solar reflectance index or SRI would mean would, would indicate that the color tends to be lighter. Or if let's say the SRI value is lower, it normally means that the surface is darker in color. All right. So of course it is combination of the two factors that I mentioned earlier: solar reflectance and thermal emittance. So here is just some examples of some of the common colors that we have, where you can see, right, starting from off-white, the SRI value is actually quite high. And as you go to become darker, then the SRI value will get reduced. Okay, so here it also indicates that if let's say the color is lighter, then it would have higher SI, and higher SI would also mean that it will actually absorb less heat, right? Just now the graphics that I mentioned earlier, the roof on the left is actually white color, and then the roof on the right is a dark grayish color. And here what you can see is that the grayish roof actually absorbs more solar radiation, hence the roof is actually hotter. And of course, the asphalt on the road, right? Those are typically in black, near black color. If let's say it's just newly paved, or it will become dark gray color. Either way, it will absorb quite a lot of energy, right, from solar. Okay, so in a way, how coming back to the embodied energy and also operational energy, this is related to the operational energy. Okay, so if let's say a building is cladded with roofing or cladding that is in high SI value, then uh, the heat gain from the building would be lower. So in a way, you will have lesser, cooling needed within the building, right? So in the long term, you use less energy to cool the building, hence lower operational energy. So that's how it works for SI value, right? So this does not just work on roofing; it also works on most of the uh, wall. If let's say it's a tall building that the wall itself is exposed to most of the sunlight, right, or even partial of the sunlight also, it will affect some level on the heat gain of the building. All right. So of course, for the metal roof, right, another thing that needs to be considered is because nowadays there are actually different technologies where it will provide so-called the self-cleaning ability. So of course, if let's say there are self-cleaning abilities to the material, then naturally it will actually be cleaner. And when it's cleaner, then the color or so-called the appearance will be also lighter. And these would directly impact the solar reflectance index as well, right? Where if let's say it is able to do self-cleaning, then the SI value for the same duration of time will be higher compared to the ones without self cleaning ability, right? So in a way, increased cleanliness also means higher SI, and higher SI means that you can achieve a, a more sustainable building that requires less or lower operational energy, right? So here you can see, different rating tools. They actually quantify, what is the SI value that is used for the roof, right? Given different roof pitch, right? Different rating tools would have different numbers, right? But what I'm showing here is actually one type of building, which is residential. But if let's say you are designing for a commercial building or for an industrial building, then there will be different, slight different requirements, right? So be sure to look out for this, scope when you are designing for your type of building. Of course, like I mentioned earlier, lighter color, also called, the color with higher SI value, typically would be, most likely would be better to reduce the energy use within the building. All right. So the last part or the last point of it is thermal transmittance, or typically known as U value, right? So for metal roof, of course, if let's say you use it for warehouses, that does not require cooling within the building, right? Then of course this U value would not be very useful because you will not have any insulation. But if let's say you are designing for a house, right, for landed housing, or for a facade of a condo or so called for commercial building, then U value would come in helpful to actually help reduce the heat gain through so called the barrier through the roof or through the wall cladding, right? So let me just explain let me just go into what are the possible points that can be scored by these different type of rating tools, which is like for example one of the highest to be scored by GPI. Of course, this is the highest possible score that you can achieve, 10 points. If let's say your U value or so called your roof thermal transmittance is so low, right? So of course, now you can't really imagine what is this for, right? But let me just explain the background behind it. So remember just now I mentioned, there are actually three types of thermal transmittance. And for the, SI value, is mostly related to the radiation, also called the solar energy through radiation, right? But for thermal transmittance, is mostly related to the conduction, meaning if let's say there is a certain temperature on the roof, on the outside, then how much of the energy is transmitted through the bulk of the roof, metal roof or metal roof system, and that would eventually transmit the heat inward, right? So that requires so-called conduction, right? So this applies to not just the roof systems, but also to the whole building envelope. For example, if let's say there's cladding, cladded like what you can see here, then it applies also to the wall cladding. But mostly it is to look at the roof, because roof itself is exposed to most of the heat gain, right, from the sun. Right, so most often it also requires you to have a certain type of what we call built-up system, meaning you will need to have a certain insulation layer, and of course there are different insulation thickness, insulation density, and so on, that would contribute to different U value, right? So here are just two examples of built-up system, which would contribute or would give different U value. So essentially, what it does is that if let's say you have just a metal roof, uh, you will have quite a high amount of thermal conducted through the metal roof, because let's not forget, steel or any types of metal most likely will have quite a strong or high thermal conductivity, right? Imagine like aluminum, it will transmit heat quite fast compared to things like plastic, right? So here you can see the arrow coming down. It means that how much of the heat is conducted through the roof, right? So here, bulk of the heat is transmitted in. But if let's say you add a certain amount of insulation, right, then lesser of the heat or temperature or thermal is conducted through the whole medium, and most of it will be get rebounds back to external. So again, this thermal transmitter or U value, it actually contribute to lowering the operational energy of the building. Okay, so how it works is that if let's say you have, because all these, the U value, right, it can be calculated based on a system. If let's say you have a higher U value, as what you can see on the right, U plus means higher U value, then the thermal transfer or conducted through will be lower. Okay, so typically the thicker you have, then the the lesser the heat is transferred. Okay, so again, different build up will contribute to different U value. So for example, if let's say you have a single roofing sheet, it will be likely that the U value will be easily more than 4 watts per meter square Kelvin. So this is the unit of U value, right? So if you incorporate a certain level of insulation, the requirements that is mostly quoted in all these rating tools, or most of it, would be it should be lower than 0.4 watts per meter square Kelvin. And if you can achieve certain U value, right, like what I mentioned, 0.4 watts per meter square Kelvin for GBI. So green RE requires 0.35, right, even lower. Actually, for this one, right, I forgot to mention, the lower it is, the number for U value, the better, because lower of the number means less heat is transmitted through the whole build up. Okay, for example, over here, if let's say a roof build up would have a U value of 0.4, compare that with a U value of another roof build up of 0.35. Then the one with 0.35 will actually transmit less heat through the whole build up compared to the one that is 0.4. Okay, so of course, if you want to achieve all that, of course, there will be a cost, that you need to incur, because you might need to have slightly more cost to finance that improvement. So of course, in Malaysia, there are still incentives by the government to incentivize people from going to green, right? If let's say invest in green building technology, or your building are certified and so on, then you can actually apply for this green investment tax allowance. So it will actually lessen your burden on financing all this green building. Of course, you can actually go to the website or MIDA, right, as well you can see from the source, to ask for more of this information or how to apply for this, right? So all in all, the intention of these 3 points, right, even though it's actually on paper is to achieve green building status, but the tangible or so-called the impact it has on sustainability is that it will actually reduce the embodied energy as well as the operational energy, so that first you will require less energy to produce the product, and second, it requires less energy to operate the product. So even though you might need to invest more upfront, but the end result is that you would actually have a long-term cost impact, or so-called positive cost impact. If let's say you operate the product in a long term. So uh, of course, when we want to go for sustainability, is always to take the long-term view, and these are some of the aspects where you can actually invest in to make sure that your building are future-proof, meaning you achieve sustainable building at the early stage when you are doing design. Right. So to summarize, there are actually 3 points that I highlighted today. So the first one is actually recycled content. Of course, these are actually segregated into two segments, where the first one is related to reduction of embodied energy, and then the second and third points are to reduce the operational energy of the building. All right. So recycled content. We talk about steel or metal roof should incorporate certain level of recycled content, and of course, based on different rating tools, there are a certain minimum threshold that you need to achieve. And I would say for steel product, it is easily 100% recyclable. So it's just depending on the source, and also what are the available technology out there to recycle the material, right? So of course, you can look into different suppliers and to feed you those information. And of course, there are actually something that needs to be accounted for, like the life cycle analysis of the product, right? How much energy is used to produce the product, and also how much energy is used to recycle the product, and so on. That needs to be seen in a holistic manner. Of course, in terms of the operational energy, we talk about solar reflectance index, which look into what is the color of the roofing sheets, right? And also how likely it is to get dirty, and so on. So it will contribute to what we call solar reflectance index, or SRI value. And typically, higher SRI value means better, lower heat gain from the solar energy, right? Then last would be thermal transmittance, or U value, right? So U value has to do with roof build-out system, where the main intention is that you insulate the whole the building, so that lesser heat is transmitted through the roof. Okay, so having a U value that is lower is typically better than having a U value that is higher, right? It's actually running opposite of SI value. Right? SI value higher means better, U value lower means better. All right, so different rating tools also give you different requirements, so you can always explore, right, which are the rating tools that you are following, and achieve those points according to your design. All right, so I hope you learned something new from today's sessions, and if you liked the content, or if you have more questions about what I've presented today, do visit us and click the button below to go to our online exhibition stand. So we'll try to answer your questions, or I'll give you a call if, let's say, we need to take this to a different discussion platform. All right, so with that, thank you all for joining today's Architects Product Talk, and we'll see you again.